Okay, hello. The purpose of this video is to go over the selective response. So as stated in my other video, I would like to have us focus on the selective response. You all are going to take your quarter one exam early on before the constructive response. So that way you have the chance to show growth in this area. Okay, now I want to highlight you're going to get your test back next time that I see you all. And your test is going to be marked up in various ways. But what the purpose of this video is I'm going to go over the most missed questions. So the most missed questions were number 1, number 6, number 4, and 8, 9, and 10. So we have 8, 9, and 10. Now, right here. So for this one, a lot of people got this one wrong because the key thing that you must know when it says factor the expression completely. So completely just means that you can no longer have a GCF in your binomials, okay? So I saw many people do this. And they saw -8, -16, and +24 has a GCF of 8. So you factor out the -8. So then all you're left over inside is x squared plus 2x minus 3. Now, if you left it like this, it would be incorrect because this trinomial can be factored even further. So here you have to think about what two numbers multiply to give you x squared, and you know x times x. What two numbers multiply to give you -3 but add to give you 2, then you're like, okay, well, my only factors for 3 are 3 and 1. And then since 2 has to be positive, it's going to be +3 and then -1. And right here is your answer. This was the lowest value. I think only 40 or 30% of students got this right out of the whole algebra class. Now, a lot of people factored this and they did like something different, like 4x minus something, and then they did 2x plus 6. This is not right, but or 4, something like that. I don't even know how they got this, or I do know how they got this, but this is incorrect because you can see that you can still factor out a 4 in this binomial. You can still factor out a 2. So this is not completely factored. That cannot work. That's why this answer was wrong. And then some people did this. So I'm going to erase this. So some people did something where they divided by 8, and then they got this answer, x minus 1 times x plus 3. But whenever you divide by that number, you are supposed to put that number back as a factor. Because if you multiply this right here, if you just multiply x minus 1 times x plus 3 and you do your little box method, you multiply, you're not going to get 8x squared minus 16x plus 24, right? And this should be negative. You're not going to get back to the original trinomial. If whatever answer you put right here gives you back the original, then it works. If not, it doesn't, and then it obviously is not the correct answer. And also making sure that it's factored completely, meaning there's no leftover numbers that can be factored out. Okay, so your final answer is the one in pink. Now, moving on to question 4. Now this says, which of the following values are zeros of this? Now the reason why this is totally many of you saw like, oh, x plus 5, you know, that's -5, and you're like x minus 3, you're like +3. I saw most people get this. But right here, this has an x. That means that is also a factor, and your only option is you set it equal to 0, so your last option is 0. So just like all of these other factors, you would do x plus 5 equals 0. You'll do x minus 3 equals 0. You also have to set that x equal to 0 because you can have a solution right there at the origin. And you can have, let's say, what is this, -5 or a -3. And then you have +5. You can have a solution right there at 0 and right here. It can look however you want it to look. But that is a possibility. So many people miss this because they forgot that x could also be a 0. And then for 6, it says, which of the following polynomials would have exactly one real solution? Now remember, real numbers are numbers that are everything but imaginary. So if you get a solution with a -4, like this, you cannot take the square root of a negative value. So this is a non-real solution. Okay. Real numbers are anything from counting numbers all the way to irrational and rational numbers. So these can be irrational. That just means you can take like the square root of 33, like that's an irrational number. And then you have rational, which means anything that's like a fraction or decimal, so like 1/2 or like 0.75, like those numbers, and whole numbers and all those other numbers that you have. Now it says here, exactly one solution. So the hardest part of this kind of question is that you have to solve for each and every single one of them. Now, there's tricks and ways for you to do it if you can see it. If not, this makes it a more complicated question. Now, right here, see, if I do x squared plus 16, I'm going to start with this bottom one, equals 0. Well, I know this is going to be x squared equals -16 when I isolate the variable. And when I take the square root of -16, that's going to give me a non-real solution. So this cannot be my answer. And then right here, x squared minus 4, well, okay, I know x squared minus 4, when I set that equal to 0, is going to give me x squared, then 4, and I'm going to get x equals positive and -4. Okay, well, and also right here I have x plus 5. That's going to give me a solution of -5. So it's just telling me for one real solution. I only need one. I don't need to do any more work. That's it. Now, x squared minus 9 equals 0. When you isolate the variable, you're going to get the square root of 9. That's going to give me x equals positive and -3. Those are two solutions, so this cannot work either. Now, this last one, x plus 5 squared, or wait, this one, x squared plus 3x minus 40. Well, that one's not nice. We have to actually factor that one out. And we'll get x and x. What two numbers multiply to give you -40 but add to give you 3? Well, 8 times 5 will give me 40. And so I want it to be positive, so this is going to be positive and this is going to be negative. Well, I know that these are going to give me two different solutions, so that can't work out either. So my only option is this one here. And the reason how I know that is when I do x plus 5 squared, well, that's like x plus 5 times x plus 5 equals 0. Now, when I set both of these factors equal to 0, they're going to be the same thing. So my only option is that I'll have x equals -5 with a multiplicity of 2. It's one solution. It just repeats itself more. So it has exactly one real solution. So your answer should have been that one. Okay, for these are pretty quick. Given the function y equals x squared plus 2x minus 8, place points on the coordinate plane to represent the y-intercept and the x-intercept. Now, what I can tell you right here, the most missed question is because nobody labeled their y-intercept. They just like forgot it or skipped it. Now, I saw many people write out the equation again,